Okay, fine. Okay, so today's topic is going to be the basics of Java and JVM. As discussed yesterday, before we jump on to any of the sessions on performance engineering, right? Be it as profiling or server-side analysis or DB analysis, we want to set ourselves as a developer, right? We need to have something hands-on to get a feel of what we are going to talk about. Before even we start analyzing few things and understanding about few concepts, the idea is to get a feel of what are those attributes, what are those heap we are going to talk about, what is the concept of stack we're going to talk about. So we're going to talk about class, method, all these things are going to be appearing in your JProfilers, JVisual VM. We're going to say this particular method is taking a response. We're going to say this object is having a memory problem. So we are all going to talk in the language of Java, but when we are going to talk to developer and architects, for us to feel confident, it is always good to have those hands-on with us so that we know exactly what we are going to talk about. So that is the intention. We're not going to go into deep dive on Java. We're not going to become a Java code programmers. No, that is not the intention, right? Intention is to get into the basics of these things. From there, I mean, depending upon our time, passion, we can expand, and then I mean, it is all up to us where we want to go in depth into Java. But more from the performance engineering aspect, I mean, it's a wide area, right? You're going to touch upon different aspects: your DBs, your servers, your network, your programming language. So it is not going to be easy to master everything, but it is very, very important to get the basics of all these things, so you know exactly what I'm going to do. And whenever the situation comes, you would have a freedom to go into deep dive in that particular time. So that is the whole idea of making ourselves comfortable, the one which we are going to work. Okay, so I was talking about Java performance engineering, right? And do we really need to spend time on Java performance engineering? Because we all know there are a lot of languages that are there in the IT world, and every year you would see a lot of programming languages coming into picture with the cloud, with the DevOps. A lot of your Python and JavaScripts are getting popularity every year, right? But if you still look into this from a statistics perspective, and from the software, from the products that are coming out from the market, right? Still, Java is still on the top. Python, JavaScript, your AngularJS, Node.js, all these things are getting popular, but still Java is very, very, very relevant to the market today. So which means whatever we are going to learn is going to stay relevant at least for 3 to 5 years. Java has been there for what, maybe 2 decades, right? And it is still relevant, and still it is going to be there. As per my experience, right, I'm into product development and solution architect last 2 to 3 years at least. I see at least whatever application we develop or whatever product we develop, somewhere in the middle layer or as a core programming service, Java will be there in any of your application stack. You take sample example is you take a database, Elasticsearch, right? Elasticsearch as a database itself is developed on top of Java, and a messaging system like Kafka, right? Very famous messaging system. Kafka itself, it's developed on top of Java, and a couple of e-commerce platforms like Ibris, right? Those are all developed on top of Java. So if you look into even any of your current application where you are going to work, is AngularJS is very popular now. You have your Node servers instead of Tomcat, but still more from the security, performance, and from the core engines, backend engines, right? You will still see Java everywhere. So Java is still relevant. That is something I wanted to let you know, because whatever time you are going to spend on learning this from an engineering perspective as well, it's Java is going to be relevant. Yeah. So no question about it. Okay. Very quick introduction about Java. I think you would have seen all these general pointers everywhere, and every time you think about Java or you search about Java, right? Java is independent about platform. You create your code in one platform, and it can be executed in multiple OS. Be it is going to be your phone, or it's going to be Mac or Linux, or even with a small Raspberry Pi kind of an OS. So it is going to be platform independent. That makes Java more popular, relevant compared to the .NET of world, right? So that is one. And second is it is open source. Of course, after Oracle bought Java, they also have a separate commercial edition of Java, but that is only for getting a superior performance and security aspects. That Oracle is marketing their commercial product of Java, but the OpenJDK is still open to every one of us to use for development, use for deployments, using it for the commercial purpose as well. It is secure, fast, and powerful. And very important thing is the community support, right? Even when I wanted to learn Java, even today when I wanted to go and look for any particular algorithm code, you will get it within 15 to 30 minutes. Yeah. When you want to go and search how to make a database connection, how to create an array, how to make an HTTP connection, how to write a Selenium script in Java, you will get everything in the Stack Overflow or in some forums. So it has a very huge community support, which means you no need to learn from scratch. Getting it from Google is not a new thing, and from a programming perspective, we never going to. At least I would say 75% of people would definitely rely on the internet to get the algorithm and choose what is the best for them. Right? That's how it is going to work. So you're going to get a huge community support from the developers. So even if you guys are not done any programming in Java, it is going to be easy for you to get started because of this particular aspect. And second, I will not say advice, my recommendation would be, even if you don't have done any programming in the past, don't get in deep into what is what, right? The definition of a few things, the templates of Java to create a class file or to create a method. You understand how it works to a certain level, and it's always going to be a template, right? Similar to in LoadRunner or similar to in Jmeter, we never would have thought about why it is structured in such a way. We use init will be there, we use end is there, action is there, and we have a lot of C functions. But I'm pretty sure some of us would have got into deep and would have understood exactly how each and everything works. But more of from a template perspective, you never would have questioned what is inside unit, what is inside action, what is exactly each and every functions are going to do. So similarly, when you're going to start with Java, we need to have a little bit of a trade-off. Understand a bit, get into practice. Understand a bit, get into practice. Don't go into detail about how exactly a main method is declared, what exactly public, void, string arguments. So I'm saying to start with, right? Because that's going to make you study a lot, and you will get lost in that. It is like iterative. You get something, learn, put it in the code, see how it works, and then go back and see what is what. So that's iterative way of learning and putting coding the Java program is going to help you to speed up your programming to a certain level that is required for your engineering work. So that is my recommendation. Start somewhere, iterate it, and then learn as you start doing the programs. Okay, but I'll anyway, I'm going to explain it through how are we going to start with the Java program, how we are going to create multiple classes, concept about class methods, all these things today. But to set the context for you, I'm saying even if you don't have experience in creating a program, I think we should not worry about it. There are a lot of support. We'll be able to start doing the program within 30 minutes, 1 hour. Um, don't worry about the definition. Don't worry about the templates. Don't worry about the syntax. You will learn as you go along with the journey. That's how it is going to work. Okay, so for Java to work, Java is a software, right? We're going to download a Java from Oracle site, and when you're going to download, right, you're going to download a couple of things. One very important thing is the Java development kit. It is like any other software, right? You go and download Jmeter, you go and download LoadRunner. So it is going to come up with a set of libraries, set of executables for you to create Jmeter scripts, LoadRunner scripts. Similarly, for Java, you're going to download a kit, a set of libraries, set of exes that is called as JDK. Okay, I'm going to note down all these downloadables as well, right? So that you would be able to uh, let me open the Excel sheet. So from where to download, in what order to download, all these things. Yeah, this is here, right? So first thing is your latest Java JDK. You can download it from here. I'll probably pass it on this Excel sheet through some OneDrive or any of the SharePoint portals. Okay. So first is we will go to Oracle and download the latest JDK. Okay. So what is JDK? What is JRE? What is JVM? You have heard about all these things. Definitely, most of you would have known about it. Some of you might not know about it. But so let me spend a minute in this, right? So JDK, as I said, it's a Java development kit, very specifically for developers who are going to create programs, develop programs, compile it, execute it on their machine, right? So it is going to have a set of libraries, like your Vuegen, for example, Vuegen, right? Maybe most of us would have been very familiar with that. So the Vuegen is again an IDE where you going to create a script, okay? And controller is where you're going to execute it, right? For a controller mission, you would not need a Vuegen. Right? It's that's kind of comparison. So JDK, you need is not exact comparison, but for you to just get a feel of it. JDK will have everything. It is a complete Java package where it will have a set of files for you to create programs. It will have JRE, which is a Java runtime environment, right? You will be able to execute it. For running a program, you need again set of libraries. To execute it, you would need a set of libraries. And JVM is your actual core engine, the virtual machine, which is going to execute your Java app or the program, depending upon the OS. If it is going to be Linux, JVM is going to call the Linux related libraries. If it is going to be Windows, it is going to call the native of Windows. So JDK is the top layer. It is going to have the JRE is a subset of JDK, and JVM is going to be part of the JRE. It is simple folder structure. What you see here, right? When you download and install, you get a Java library, Java directory, where you will have all these JRE related libraries. You will have JVM. Let me quickly show my desktop as well. Depending upon the Java version, what you use, right? Couple of things will vary. Before Java 9 or Java 10, I guess the concept of JRE was there. After Java 9, I guess they removed JRE, and you would see every other library is part of JDK itself, right? So let's not worry much about it, whether Java 8 or Java 9 or latest Java. The latest Java will look like this, right? It will have the bin folder. Inside bin, if you go, you will have something called jvm.dll. This is the JVM for the Windows, right? For the Linux, you will see a different extension. If it is going to be a Mac, it will be different, right? So JDK, it's a JDK, you will have JVM, but you will not see anything called JRE here. Okay, because as I said, by default, when you're going to download, I guess now JRE libraries are merged, and it's going to be inside all the library itself rather than the subfolder called JRE. Let's not worry about all these things, right? Still, the Java runtime environment libraries are going to be there within JDK. Wherever you're going to develop or wherever you're going to execute, you would need the JDK package, or you would need the JRE package. Okay. So going back to the slide, to keep it very simple, JDKs are Java development kit for developers. For you to get started, you need to download the JDK, have it in your machine to start the programming. If you're going to do only execution, say for example, instance, to use Jmeter, to use Tomcat, right? You're not going to do any development. You're going to use the few softwares like your Tomcat or your Jmeter, for which you would still need the Java, right? You may not need an entire JDK kit, but you would still need the libraries for execution, right? Um, for that, let me show you that as well. I have another mission where I have downloaded the uh, Java, where I would have got only the JRE, right? So this will have the libraries for me to just do the execution alone, right? With this, I will not be able to create any Eclipse projects. I will not be able to develop projects, but I will be able to execute it. Let me show it, right? Before showing how exactly this JR is going to help us in Jmeter or Tomcat, the next part is so when you're going to do a programming, right? A couple of things you have to do it. One, as I said, you're going to download the Java from your Oracle website, and then you will see once you install the Java, you will see JDK directory in your machine under program files, and you will see a lot of libraries got installed, and very specifically your Java.exe would be there in the inside bin. If you see, there'll be a lot of libraries. If you, for example, we have seen the couple of monitoring tools, right? JConsole, it will be there inside the bin. JMap, JStat. So all the things which is required for us to debug, monitor, all those libraries also going to be part of this JDK kit. Okay. See, JVisual VM also used to come along with the JDK kit. If it is missing, we can even download it separately. I will show when we go into the profiling sections. I will show how to download the other additional monitoring tools as part of the JDK kit. But this JDK inside bin, you will have the necessary default. You will have the main java.exe. You will have the compiler Java C, and you will also have, as I said, JConsole, JMap, JStat, all the things that you might have heard earlier. That is going to be part of the JDK kit. Okay, so now we have our JDK kit, everything installed, downloaded, installed, and it is available for us to see. Right? What is the next thing? Setting up your Java environment. Whenever there's a software that's going to run, like Tomcat or Jmeter, it should know where the Java is running. So we need to set the environment variables. Okay, let me show what it is, what will happen without doing it properly. Okay, so I'm going to a mission where I have similar what I have, as I said, right? I have a Java downloaded. Let me go to the command prompt, and then let me check for the Java version. So it says Java is not recognized as an internal or external command, which you would have seen it a lot of time when you are trying to use it for your other softwares. Classic example is here. I would say Tomcat, right? Say for example, Tomcat, as I said, it's built on top of Java. If I'm going to start a Tomcat server, right? Let me do that. So I'll say startup.batch. It will say neither the Java home nor the JRE home is defined. So you will get this message in most of the places. Okay. Not only for Tomcat, whichever software is developed on top of Java and depend upon Java, it will throw this error. Similarly, for say I go to our Tomcat Jmeter, okay, and I go and start the Apache Jmeter. So it will say again Java is not recognized here. Okay, so let's quickly go and configure it. So there are three things we are going to do it. Let's go to the environmental variables. So if you go and search for the system environment variables, right? We'll go and get it. You will be able to go and set up this Java home, set up this JRE home, add the path where the Java is installed. Okay, so you will get this panel where you have to go to environmental variables, and then system variables, user variables. If you are the only person who would use a system, or it is going to be shared across multiple people, it is always good to add it in the system variable so that it will be available for everyone. If you're going to add it this in the user variables, it is going to be only for the particular user who have logged in. So let's go and add it in the system variable. Okay. Um, the first thing is I will add something called Java. Okay, and then I'll go browse the directory. I'll go to the libraries. I'll go to the uh, C, and then program files. It is there in the uh, Java, and then JRE. Okay, so this is going to be my Java path. I have added. I'll just copy it, and then I'll add one more thing called Java home. So a couple of softwares will look for one or two different variable names. So common are Java, Java home, JRE home. Okay, so let's add this, and also for the execution to find the Java path, I'll go and add it in the path. So where I'll go and add a new. Yeah, I'll just move up. Yeah, so just add it, and then click OK. So now I have added Java home, and the path I have given the Java path as well. Okay, okay. Now I have to close the command prompts, and I'll come back to the uh, command prompt. I'll close this as well. We have to open a new command prompt to exactly see the Java version. Java version. So sorry. Let me see what is happening there. Let me close it again. Did I save it? Let's view a bin as well. Okay. Java version. Yes. The mistake what I did is in the program files, Java is there. JRE, I gave this as the Java path, but the java.exe is there in the um, just 1 minute. Let me uh, plug my charger. 1 second. Okay, fine. So the mistake what I did is I just gave this JRE path rather than it has to be the bin path, right? Because my java.exe is there in the bin, so that is why earlier it was not working. So that's a very common mistake. What it is, I do it. So now the Java version is there. Now if I go to execute the my Tomcat, it should work all fine. Let's do one before we go to the next topic. Bin, and then start up. Sorry, CMD. Now Tomcat is getting opened and it is deploying whatever files inside that. It is started. Okay, so that is how it is going to work for any new machine, any new server, wherever you're going to download the Java or JRE. So you need to set up the Java home and the path pointing to your bin directory wherever the Java exe file is there. Right, that's a one-time setup. You have to do it. Now you are all done. Now you are ready to create Java programs, execute the Java programs. Okay, so this is the all about setting up your environment for the development and runtime. Okay, then next, as I said, while creating programs, right, there are a lot of things you will see in the general templates. If you go and search for sample Java programs, you will get a lot of things in that depending upon what exactly algorithm you're looking for. But the general template will look like this. And one from writing new programs, by us and so on. It is very minimal to know about just these things, right? There are going to be 100,000 things which is going to be there appearing in programs when you're going to take algorithm, take the code from the internet and use it. It will work. A few things you will know what it is, few things you will not know what it is. But these are the few important things we need to know. And even these things are going to be pretty much you would see all along the engineering as well, right? The way the primitive data types are going to work, the way non-primitives is going to work. It is going to, we are going to talk about in when we are talking about the memory session next week, right? So these things are going to be related to memory topic. How JVM is going to handle your stack memory or heap memory. So this is going to be relevant to us. And the general skeleton, right? Most of you know about the class, object, method, the package name, the imports. So these are the skeleton above on the any Java program. What is class? What is object? Again, it's a the very basics of Java where every other Java programming sessions are going to get started, right? So let's not jump deep into how exactly Java as designed this class and object. But for us to know the very simple things about class and object, right? So every program when you create, you're going to save it as a .java file, and when you go to compile it, it will be a .class file. So you're going to create n number of Java files, n number of class files. In any Java application, it is going to have hundreds of class files depending upon the size of your application. So what does a class all means? Class is going to have the definition of your program, right? It is going to have a set of variables, data for you to handle it. Like it could be integer, it could be a boolean, or it could be a string. So it is one is a state. They call it as state, right? It like your name, age, color, sex. So the class template, when you're going to create a class, you're going to declare few variables, and then you're going to create few methods which is in your actual operation. It is going to be for simple adding up two numbers, subtracting two numbers, printing something, connecting your database. So all these things are going to be in a method. Method is a set of operation which is going to change the behavior of few things, right? And object is more about an instance of the class. Say for example, you created 10 class files and it is available in a jar, right? And from a web application, from an amazon.com, there are going to be 10 people who are going to hit amazon.com and they're going to do some add to cart checkout. So whenever there's a checkout class is called, say I'm going to do some checkout. For me, it is going to create an instance of a checkout class, which means within the checkout, I will have my data. My data would be, there will be 10 items, and the price would be $100 or 100 rupees, right? That is a one instance of the class file that will be loaded for me. And similarly for you, you might have added say just one product of $200. So this product quantity as one item dollar as $100. That is something the state of the class which will be altered for you alone, right? So there's a template available called as a class file, which will have the data, which will data type, which will have the code operation, which is going to calculate the price. For example, right? Yeah, water bottle cost would be a $10 and quantity of 5. So to calculate the total price, those operation will happen within the method. To declare saying there's a water bottle, the quantity as 1, that is going to be declared within the class. So when I'm going to access it, for me, the object is going to be created of this class, which is an instance, which means for me it is water bottle, for me it is quantity as 1, and then in the method the prices will be calculated. For you, the item name could be a different laptop, and quantity could be 2, and the inside the method, the total price will be calculated as 2 into price of a laptop, which means for me it is totally behavior. I'm having a different values for the state. I'm having a different behavior, and for me it is going to work separately in a thread. For you, it is going to separately work in a thread, right? So to keep it very simple, for you to understand what is class, what is object, I just gave this example, right? Class, you create a one program template and deploy. When somebody is going to access it from the outside world, for each of the user, the object instance would be created, which will have its own property as per the input what you're going to give it from the front end. Okay. So for this example here, right, I talked about the e-commerce way of example here. In this slide, you're talking about a class as a student. When somebody is going to enroll to a session, right? Say for example, for this programming performance engineering session, you have enrolled. Each one have enrolled. So each one will have your name, your age, your color, your sex. So somebody, if you want, they wanted to, if say for example, Isha wanted to register you into their system. When they're going to register, they're going to call the class as a student, where they're going to get an input there are going to be 10 different names. For each name, there are going to be different age, color, sex, and then depending upon what they want to do it, right, they might have to wanted to attend the Java engineering class. Somebody would have wanted to attend the LoadRunner class. For each of these sessions, the cost would be different, the fees would be different, the duration would be different. So all this behavior would be changing, but I will have only a class called student, and I'll create object for somebody called Kiran. There'll be object for somebody would be for Navin, and each one is going to work on its own without disturbing the other. Object one will work on its own, object two will work on its own. Uh, that's how the Java program is structured at a very basic level, right? I'm again not a big Java expert, but to keep everything simple for us to get started, I think we will get started with this definition. We are going to create class. We are going to, inside the class, we are going to declare few variables, and we are going to create a method, and method is going to do some operation. From a data perspective, from when you're going to create a variable, there are two types. One is primitive, one is non-primitive. Primitive is something defined as a what to say, a keyword within the Java itself, right? Int, boolean, byte, character, all these things are called primitive. There are a lot of primitive data type. We don't need to worry really about get into the detail, but primitive word is very important for us to get into a memory session. We'll exactly talk about from the memory concept how this primitive is going to vary, how non-primitive is going to vary. Non-primitive is more about creating strings, arrays, your actual class, right? Whatever you're going to create, that is also going to be called as non-primitive. Okay, and everything else, whatever you're going to declare, it is going to hold memory, right? Just wanted to highlight that all these things are going to have at least a byte or two occupied in your memory. Okay, and from a Java program skeleton perspective, we talked about class, we talked about object, we talked about method. Package is nothing but we are going to create multiple classes. Everything will be packaged. Let's call a package. Imports. So import is all about, I would say, to keep it very simple, copy paste. We need to go and create programs. It's all about reusability, right? Somebody would have created some programs for making an HTTP connection, to make a database connection, to run a Selenium script, right? So we no need to go and do it in a scratch. For example, again, LoadRunner function. If you take an example, right? In LoadRunner, there are a lot of C function. Your think time and your start transaction, end transactions, your string concatenation. There are a lot of C function, right? Inside that, there are going to be code, but we are not going to worry about the code, how it is going to work. You're just going to import the LoadRunner libraries, and we're going to call this function. Similarly, in Java, there are going to be a lot of imports for every action, right? You create your own algorithm, but for the other things, you will import the other jar files. So we'll also talk about those imports, which are going to be very important for your program to run. Your algorithm is going to work for only for your exact operation, but to do anything additional to interact with database, to interact with the your local file handling, to make an external call to an HTTP servers, right? For all these things, I'm saying very simple examples. We don't need to break our head on how am I going to do a HTTP connection? How am I exactly going to do a DB connection? All these things are going to be part of a jar file, which we can download it from the internet, and you can load it into your package, and it's just do an import. Okay, so this is the basics you wanted to know before we jump on to creating the any programs which we are going to do it. Okay, so let's do some coding. Okay, what I will do is I will open the Eclipse. I will walk you through these simple programs, and whatever issues that you are going to encounter during creating new programs, I'll probably try to walk you through. Um, uh, to get started, as I said, right, we're not going to create hundreds of code for us to get a feeling of Java code. So more about templates, more about what you're going to use it, and from there you can think of whatever algorithm you want and get that into a Java, right? When I say algorithm, I want to get some two inputs, I want to do some addition, I want to write into a file, upload it to a HTTP server, insert the data to my database. So you think about all your frequently used activity when it comes to your way of work, right? Try to automate using Java. So define your own requirement, define, think about how are you going to do it. Go and search in Google, you will get that algorithm there. Put it here, see, learn how it works, and then run it. You will end up with the problem. There will be a lot of exceptions, compilation error. You will try to fix one by one, and at some point of time, you're going to get a comfortness about creating programs. Right? It is not about getting expertise. It is more about getting at a certain comfort level. To begin with, let's do this. I'm going to use Eclipse. Again, Eclipse can be downloaded. I think I have marked down from where I do. Yeah. See, first step is you're going to download the Oracle, say Java from the Oracle site, and then you're going to set up your environment, and then you're going to download the Eclipse. From this path, you can download the latest enterprise Java edition, so that later you can also use it for developing a web application, right? So download it this particular path. Okay, so I'll go and open the Eclipse, which is already there in my system, and all these installables are very simple, straightforward. You don't need to really worry about how this installation is going to work. It's very straightforward. Next. It will get installed. While installing the Eclipse, it will directly look for the Java path. It will self-configure, or you might have to provide the your JDK path. That is the only input you need to give for the Eclipse to work. Where is your JDK path? So that by default, whenever you're going to create a program, it will work by default. Okay. So let me go and do this, right? The order in which we are going to do it, we are going to create a simple Java project. We're going to create a simple one class file with one main method, and we're going to create two class file and then call method of a second class file from a first class file. That's how a typical programming is going to work, right? There are going to be multiple class files. You're going to create multiple methods which can be reused. You're going to create one method from another class file, vice versa. So we'll try to do these simple things, which is going to be a template of any applications, right? And we'll then create a little bit of I will not say complex. We have a different variety of a program where it will require for some other external jar files. Okay. And then we'll go on to the next topic of how are we going to package it? How are we going to create a jar file? How am I going to create a what file? How am I going to deploy it? Right. These two things we'll look into it in another 15 minutes. Okay. So I will open my Eclipse. Okay. So when you going to open your Eclipse first time, you will not find anything in the project explorer, right? So there are three things which you need to know very basics about this. It is like any other IDE, right? In your performance center, in your view gen, you will have a place where you will go and do a scripting. and you will have a place where you'll be able to look into all your previous projects or all your packages, all your programs which you have developed, grouped under each project. Each items are your projects, and inside the project you will have your own programs. Okay, first time when you're going to do a new project, right, just go to the file, click new, and create a project. It could be there are a lot of different projects are available, right? Let's not worry about it. Let's go and create a project, just a plain project, Java project. Okay, just give a project name as my job. Okay, and automatically it will point you to the it will ask if there are a couple of Java version available in your machine. It will ask which one you want to select. It could be a default JRE. I will select this and then give next, finish. You can, if it is going to ask you to create some module info.java, you can just skip it. Yeah, so just do these things, and you will have your new project created called my Java. Okay, inside this my Java, my next step is to go and create a Java file, right? My project is now available. Now I'll go and create a new class file. Okay, this is the order you will do it. And when you create a first class file in your project, you just give a name as some demo one class, and then you want to just select this as the default option of public, and then you select this option as a public static void main. For every project, or there should be one your main method. When you're going to execute a Java program, your Java program, your JVM will look for a main method. So you, at least in one of your main class, that could be 5 class, 10 class files, and you will be calling each other class files, each other method, but there has to be one entry point, right? This one entry point, to keep it simple, you can think about user init, right? Your LoadRunner script will always start from user init, and you will have only one user in it. You can have multiple actions, but you will have only one user in it, right? So similar to that, there has to be one main method as an entry point. So just select it. Don't worry about how exactly this is going to work. Again, I'm saying let's go with a template way of creating a Java program. You created a project. You're going to create a class file. The first class file have to have this public static void main selected, and then go and finish it. Okay, now you all set to create a new program. Okay, so this is the one which I created probably a couple of hours before. Exactly similar to this, right? It is having nothing complex. It's very simple things. I'm having a value one called an integer, a primitive data called value one, which I'm saying is a value of 10. I have declared another value of int as 12, and then I'm doing the operation called value 1 plus value 2, which again I'm storing it in the integer called sum. I'm printing it out. Okay, I'm doing nothing else. This is the very simple, very starting point where to make sure my class file works, whether it compiles properly, whether it executes properly, whether to see my Eclipse is working properly. So for that, I'm not bringing in any complexity. I'm just declaring few integers. I'm doing an operation, and then I'm printing it. Okay. So the way it has created, right? It has created a class file. The name whatever you gave it while creating the class file. So public class first program, and inside that you're going to have the main method, public static void main. So this is again at common syntax. You will get it. You don't need to worry about exactly public and private. If you want to really understand, it's very simple as English. Public is available for anyone to call from outside. Private is very private, where you will not be able to access it outside world. JVM will not be able to access it directly, those methods. Okay, so that's a very simple explanation of public and private, right? Let's once you get an understanding of how the program works, then you can get into detail about how exactly static works, how void works. Don't worry about it when you go to start programming, because once you go into this, you will get a lost a bit, right? You will get confused because not everything about Java you will be able to understand very easily. A lot of things are concepts. We're not even talking about OOPS concept here, but OOPS concepts are very important for you to do a program in an effective way, to know exactly how each and everything is going to work. How are you going to create multiple classes, multiple programs? Our intention is not that. Our intention is to understand how Java program works, to create programs, to compile it, to run it, to know how the data type works. So for that, let's keep it as a template. So I created a method, and then I created the primitive variables. I'm going to run it. So for me to run it, I'm just going to right click it, and then I'm going to run as Java application. Okay. So to see what happened, right? Normally, it will be there in the console. Okay. The console for you, sometimes it might not appear in the right panel. So for that, you have to go to the window. You have to go to the show view, and there is something called console. It will appear here. So maybe by default, first time it might not show it here in the right hand side navigation bar. If it is not showing, you will not know what exactly happened, right? It got executed, whether it gave you exception, or it gave you whatever it is required. For that, console is where it will get printed. So here it's saying I'm in the main method. I'm in the value is 22. So that is what I printed here. So my Eclipse is now working fine. My first program is working fine. So I don't have any problem with my environment. Java is recognized properly. And if you see this, right, there is a demo1.java, and this class file is created. So for every Java, there will be a class file will be created, demo1.c, the demo1.class file, right? So Java, the Eclipse has compiled my Java program. It has created a class file now. And then when I'm going to create my second program, right? Now I've created a first program. Simple thing, simple class file, everything worked. My environment is good. Now I'm going to create a second program. Similarly, whatever we have done there, I'll go to file, new, create a new class file. Now I've created a second program, but here if you see, I haven't created the main method here. I have just created a method which can do some operation again. So what I'm saying is I have created a method called public again, which can be accessed outside of this class file. So if I want to access this method one from first program, I cannot have it as a private. It has to be a public, so that this method, whatever method you are declaring within the class file, if it is going to be public, I'll be able to access it from the first program. So public, and then it is going to accept the integers. It is called a method one, and it is going to accept. So as I said, right, a method is an operation. I explained to you earlier. Say in the case of e-commerce, right, it is going to get an input saying I need 2 quantity of laptop and I need a laptop, right? So it is going to accept a quantity 2 as an integer. It is going to accept it as a string as laptop, right? So method one will, for our example, I'm going to accept 2 values, value 1, value 2 from the outside world. Outside world could be another program, or it could be a front end. So this public method one, the second program, it's going to accept the value 1 and value 2, and then it is going to do an operation, right? Sum equal to value 1 plus value 2. The sum is something will be returned to the whichever program is going to call this method, it is going to return this sum value. Okay. If you look into the first program, I would have given void. Void means there is no return. Here, I will not give void because it is going to return something. So that's a difference between whether to give void or not. Don't worry if you really don't able to get what is void, void to void. These are all again very basic things. Keep it at a basic level. Don't go into deep. I've created a one program, first program.java. I created a second program. I created a method which can be accessed outside. That is why I've kept it as a public, and I'm accepting the values from the outside world called value and value 2. Inside my method, I'm doing some operation. Considering our e-commerce example, I will calculate my price and I will return the price to the outside world so that you can see it in your UI. It will say the price equal to number of laptops 2 into price of each laptop is $1,000. it will return as a $2,000 for me. In this case, I'm just doing a summation of value 1, value 2. Okay, so I created this class as a second program. I created a method. Now my second program is ready. Will I be able to run this second program directly? No, there won't be any option at all, because there is no main method. There is no main method. You will not be able to run the program directly. You have to run it from your main method. So how are you going to do it? So we talked about class, we talked about method. Now class is a template where it will have the variables, it will have some operations, or it will have the variables, and get the input. It will have a method, it will get an input, it will do some operations. So we have seen about how the class is going to look like, how the variables are declared, how a method is going to work. Okay, now we will go and create an object. Now if I have to pass this input to the second program and call the method, I cannot call this method directly. I have to create my instance, because as I said, I am going to use this program for my cart where I have ordered laptop. For you, it might be a mobile, right? So for that, I need to create an instance of the second program. Otherwise, it is going to be all messy, right? I have ordered a laptop, you have ordered a mobile, and when it is going to run in parallel, Java will not know what to send to a user, whether laptop or mobile, or which price, which quantity. So for that, for me, I need to create an instance, right? When you're going to hit a submit, it will come to JVM. JVM will create a thread, and that thread is going to create a what to call this class, and it's going to create an instance of this second program. How to create the instance of the second program? It's simple. Again, a template. Um, the variable name is going to be your class file name, second program.java. So second program followed by object name. Object name is instance, my obj, or you can put whatever name you want, right? You can say my op, or my operation. You can give whatever object name you want to give it, equal to new instance. So you will create a new instance for you under the name of my operation. Once it is created, you will be able to use this instance variable called my OPER, and then you can use the method. So what will happen is, when you type my OPER dot, it will list down you all the methods that are available for public here. Okay, say in the second program, we have created a method called method1. So it is here, and then it will automatically, it will show what it is going to accept. It will accept whatever variables you have declared there as a public, right? It will appear here. So value 1 comma value 2. So you have to pass the value 1 comma value 2 as yeah. Okay, that's it. So now what you did is, you create an instance of your second program so that you can access the method. So you use the my OPER dot method 1, and you have to pass the value 1, value 2, because your program will expect two values here. If without that, this won't work. The input you have to give it from the first program. Input, for that input, now we have declared it here. Ideally, it will come from your UI. In our case, it will come as a quantity. It will another variable will be string called laptop. So laptop will come, quantity will come. That will be passed to your second program, and in the second program, it will execute and create the quantity. It will calculate the price, and it will return the price. That's a comparison I'm doing it with e-commerce, so that you will be able to really understand how exactly it is going to work in the real world. Okay, so now I created an object, and I call the method, and I will be now able to execute it. Okay, for our understanding, I have kept a couple of print statements where I'm saying I'm inside the main method, and then I'm saying I'm inside the second program method, so that you will know exactly how the flow has worked. Okay, now I'll go and execute this. Okay, so let me go and search it. Okay, you're saying I'm in the main method, sum is 22. I'm in the second program method, sum is 22. Okay, so this is what it is printed. It has come here, it has printed this, and it has calculated the sum, it has printed the sum. Okay, so that's how the the basic program is going to work. You can create n number of programs, n number of Java files, and then one of the class file would be your main method, and then you can call the method of your second program, second class file, creating an object, and then you can access those methods, whatever that is there. If you want to add another method, you can also call that method. You need just create one object, and then you can calling the method multiple methods sequentially. Okay. Okay, I'll just take a pass here. Any questions before we go on to the another programs about where we are going to invoke external jar files, connecting to a DB, making a HTTP call. A few basic steps we might note, we might have to know for you to get a feel of the entire programming. So, any questions you have? I'll just take a pass here. For a few of you, this might be very basic because you might have already done programming. Few people who might be you wouldn't have done it. For you, it will be definitely useful. But any questions you have, I can answer it.
Oh, hello, Prem. This is Kirti Kumar.
Yeah.
Yeah. So you told about a few classes are created, right?
Yeah.
One is a main, and we can create n number of class files. So if you take that your Amazon example only, so if it is written in Java, so like that n number of class files are created based on the operations, how it has to work, and will for each user one object is assigned, and based on the operation each Java class files will be called to execute in the real world, right?
Exactly, absolutely. One layer above this class file would be your threads, right?
Okay.
A thread will be created by a JVM. So there will be some 10, 20, 30, 100 threads that will be available for you to access this class file. Thread is a more of a channel where you'll be able to do the execution. So as you said, there are going to be n number of class files as per the functionality. For if you see the Eclipse here, right, for our library project, library application, add book, delete book, add a user, issue book. Each one
Correct.
is a Java file. Inside that, if you see, to add a new library book, there will be something called, you will be getting a book name, you will be getting the author name, and you will be calling the database, you will be inserting it. That functionality will be there in the task file. So for you, when you want to log into the portal and you as a librarian, you wanted to add a new book called Java, the UI will say Java written by author so and so, and it is available for from tomorrow, and it is available for price of $10, $20. Would you give it? There it will come when you go to hit a submit. It is going the available thread is going to take that your call. It is going to call the particular adbook.java. It is going to create an instance of this class file, and it is going to pass that value as Java, and then author name. All these things will be put into that assigned into that variable. It is going to call the method, and the method will go and put it inside the database. So that's how it is going to work in the real world. N number of class files. All the class files will be defined in such a way that it is very functionality. You can compare with your scripts, right? Your LoadRunner scripts, Jmeter scripts. You create a script for login. You create a login for checkout. You create a login a script for view statements, add transactions. So it is again a logical grouping of how you want to do it. So in this class, in this example, you see it, right? All these are functionalities. Your business requirement, delete book, admin login, all is a business requirement, logical functionalities. So you will create multiple class file, and this will be called as an instance for you to do your own operation.
Okay, if the clients comes and they tell that they're going to introduce a new functionality like some functionality. At that time, the developers will go and create one Java class file and just invoke that class through an object and use that functionality, right?
Exactly. Yes. Yes. See, tomorrow. See, today there is nothing called delete book. If the
Correct.
customer is saying they want to have functionality away from the UI, I can
Uh-huh.
also go and do a delete the book because it is very old. Maybe
Oh.
talking about LoadRunner 8 or 7, it is not even in use, which means there is no book required. So if somebody has to delete it, it will come here. It will create an object for delete book, and it will go and delete that particular entry in the database.
Okay. Okay. And another one is, so all these logics will be there. These are the actual basic logic of an application. So all this will be in the application server. These logics are application servers, right?
Correct. Correct. So, since you asked this question, right, I will show you how exactly it is going to happen from a deploying it perspective, right? So, I created all these programs. Now, I'll be able to go and create a jar file or create a war file, which is a deployable, right? So, all we get is now I have 5 classes, 10 classes. Now, let me go and export this. I'll just pick this one of the project, right? There are one Java file in this. I here go right click it, and then I'll go and export. And when I'm going to export it, it is going to ask whether I am going to do it as a jar file or a runnable jar file. So the difference between jar file and runnable jar file is runnable jar file will have a main method, which means you can execute the jar directly.
Okay.
There are, if it is going to be a support file, for example, you would have added lot of jar files in your Jmeter, right? Not everything is going to be the main jar file. It's all support jar files. So if your main, if you whatever you are going to package is a main jar file, it will be a runnable jar file. Okay. So click next, and then just give you wherever you want to store, finish it, over it, done. Okay, now my jar file is available here. I will go to my C. I'll go to my dev. Here I have saved it. Okay, there's something, a jar file is created. Now to execute the jar file, I'll go there. So once, what we'll do is we'll distribute this jar file to other people whoever wanted to use it. Okay, what they will do is they will get this jar file. They will go Java hyphen jar memory issue.jar. They will execute it. So this is started doing something. It is in main method. It is in method proc done. Some activity is just done. Yeah, over. So this is how you are going to deploy it for a jar file. If it is going to be a war file is for a web application, right? Whatever program we have created here, it's all standalone Java programs, not a web application. Jar is your Java archive, and war is your web application archive. Okay, so this E library is a web application. The way you create in Eclipse the web application is you have to go to new. If you've seen earlier, right, we have created a project earlier. So when I go to create a project for web, I'll go here. Okay, instead of Java project, I'll go to web, create dynamic web project. Okay,
Okay.
which means now it will have a template for creating my HTML files. It will say which Tomcat this will run, so that the project will get optimized accordingly. So these configuration will give it, and then you will create a dynamic web project. If you see here, right, there will be something called web will be there on top of practice. The last one, this practice, there will be some difference between a Java project and web project is you will see a globe on top of it, say in
Yeah.
E library. Then you'll be able to export this into a WAR file. So here I'm going to export as a web WAR file, not as a jar file. So I'll do WAR file next, and then I'll give a path where it has to get saved. I'll say here and then finish it. Okay. So now my WAR is available here. Yeah, yeah. We just created it, right? So this is how you bundle your programs into a jar or into a war. Anyway, I want to cover it in the next slide, next section after completing the program. Since you have asked, the developers will create a lot of programs. Either they can distribute as a jar file, or you can distribute as a WAR file, and this is how you're going to do it. So that is very important for you to, when we talk about jar WAR, we know a lot of jar files we'll get it for our purpose, for our execution. We will get WAR file for deployment. But from a developer perspective, this is as simple as creating programs, exporting into a jar, exporting into a WAR file, and you can go and deploy it in the Tomcat. That's it. Okay.
Okay.
Prem, if we have already a code snippet which is developed by some developers, they given this code snippet to us, how we can open this in Eclipse, like already developed code snippet?
Okay. Okay, good. So
in this
what
ID, like Eclipse ID.
Correct. So you have to just import it, right? You're going to save that source file, okay, and you can open project from file system, okay, and for example, this e library I downloaded it from the Java Point website. I downloaded the WAR file. I also downloaded the entire source file. Okay, if you go here, so this e library is the one which I downloaded. Okay, it's just when you go and download, I got this e library. Okay, inside this e library, I'll go there. So this is the one which I downloaded, and inside that you will have source, you will have web content, you will have build everything. Inside source, you will have the servlets, you will have all these Java files which you saw there. Okay, this is the structure of the example. You got this package from a developer, you download it to your local machine, and then you go and import it. Go to the file, open project from file system, you give the directory, and then you go here and then say e library, dev e library, and then select folder. Okay, it says file folder already imported, this one for me. If not for you first time, you will be able to go and import it. That's it. Next, finish. You will get it here. And now from here, you can go to your source, go to servlets, and you will be getting all these things. Since it's a web application, they would have handled it, all the database activity connections in the under the name of .dao, and servlets will have the your all the class files related to your functionalities, and all your web related HTML content will be there under the web content, like all your HTML files. Okay, and yeah, that's how it is going to work in case of importing the available packages to your Eclipse. Okay. Okay, so let me talk about, so for today's sessions, right? The things what I want to cover is yeah, creating the Java project, creating multiple class files, and then I'll show you what will happen, how to use the external jar file. Say for example, I created a jar file now. I can distribute this to some other people who can import it, and they can use my methods, right? They don't need to create a new method again. To say for example, I created a class file for calculating the price. Somebody wanted to use it again, they don't need to code it again, right? They can use my jar file. So how are we going to use the other external jar files? How are we going to import it? So those things we'll just look into it in a minute or two. So but I just want to show you with the remaining time, we have 15 more minutes, right? 15-20 more minutes. So after this, what we will see is, anyway, I think I covered the jar and war as I spoke and answering the question. Deployment is something pending, which I will show it. So we created a jar file. We will also created a web project and a war file. And then deployment, I will show it anyway. And then I wanted to spend a good amount of time in JVM architecture, which I don't know whether I'll have time today, because I don't want to wrap it up fast on this JVM part, right? Because that is where our engineering is going to also start with this. So I don't want to rush it. I would need at least 15-20 good amount of time to explain you all this architecture. So I think maybe since it's a last demo class, right? I'll wrap it up quickly, but we will again start over on Monday. As part of the day 2, I'll again go into into the deep discussion about the JVM architecture. But since it's a demo class, since many of you have joined, I will also anyway quickly cover about the architecture. So let me do one thing, right? About the DB connection, the HTTP call. Let me park it here. Now I think many of you would have got a very fair idea about how to use the Eclipse, how to create programs, how to call methods, and how to execute it, creating jar var. About the external files, how to do a couple of other things like making HTTP call and all. I think we will look into it maybe on a little later Monday. We'll definitely cover it because for you to get started with the programming to a certain level, these things are going to be anyway important. But since the demo class, let me not spend time because we have just 15 minutes. So with this, I will move over to the JVM part. Okay. So we completed 1, 2, 3. 4 and 5 is very important because for you, we are going to download a lot of external jar file for you to do your own programs. So it is very important for you to know how it is going to work. During runtime, there are going to be a lot of problems. We'll look into it on Monday, 4 and 5 for sure. Okay. Jar and var, yes, we have seen it. Deploying it in a Tomcat again, will cover it on Monday. Yeah, this JVM architecture, right? Now you have seen class, you have seen objects, you have seen methods, okay, and you have seen .java, you have seen .class. I don't want to start this JVM architecture at the beginning, though it is very important, because if I would have talked about all these things in the beginning, it would have been pretty theoretical for you. Now, at least you would be able to make relevant of what I'm going to talk about, right? So ideally, you're going to create a .java file. It is going to compiled when you're going to in Eclipse. It will compile it on your own. If you don't have Eclipse, when it is not about saying you don't have Eclipse, right? Everybody has to an IDE. In simple word, it is going to call the Java compiler. There's some library called Java C. When you go into call Java C followed by your Java name, it is going to compile and it is going to give a .class. But let's not even worry about it because your IDE or your Eclipse is going to do that job. If you create a Java program, now a .class is available. When you're going to have 5 class file, you're going to have 5 Java file, you're going to have 5 class files. What is going to happen when you're going to give right click, run as a Java application? It is going to go and create a process inside a JVM. What is going to happen inside your JVM? That's about your JVM architecture. First thing, it is going to load all your class files. Whatever you created, there are going to be 5 class files which you created in your project. It is going to load. It is going to load the Java native class files. There are going to be a lot of class files we see in the JRE, right, in the path. A lot of support for your program to work in your Windows. It is going to have a lot of other libraries which you don't even have a clue about what it is going to do. System libraries, okay, and then external class files. You would have imported library for making a DB connection, for making a HTTP connection. So you would have got a jar file from your other teammates. So all other class files will be loaded as part of the class loader. That's a very simple thing to say. Inside class loader, there are a lot of things that is going to happen. As I said, it is going to load. There are 3 things: load, link, initialize. Okay. Again, all these things are black box. Even for a developer, it is going to be. I would say for a senior developer and architects, they have to know all these things to solve a lot of problems. But at a junior level, it will be still a black box. There is something called a class loader in a JVM, which is going to load the class. And class loader is going to have 3 components: load, link, and initialize. Load is going to load all the jar files, all the class files, your class file, external class files, system class files, everything. It's going to load it. Then second comes your link. In the link, there are going to be 3 sections: verify, prepare, and resolve. In the verify section, it is going to verify the class files whether it is suitable for your JVM to handle it. So there are going to be some standards which will validate, because you're going to create your own programs. You're also going to import a lot of other Java programs from other people. You're going to download jar files from the internet. So it is going to verify whether class files are as per the JVM version that is installed in your machine. So as per the linking process, it will do the verification, and then it is going to prepare. When I say prepare, right, it is going to assign a memory or assign some default value to your primitive objects. We talked about primitive objects, right, like your boolean, integer. So it will assign some default values to all the primitive variables as part of the prepare statement. And then in the resolve component, it is going to see from one class file you would have called another class file. So all these references, whether it has been done properly, so all those syntaxes related to the linking of these class files, multiple jar files, that is going to happen in the resolve. It's going to resolve the mapping, resolve the linking between the classes, references between the classes. Let's not worry about exactly what happens inside. It is going to load the class file. It is going to verify whether the class files are valid. It is going to assign some default values to all the primitive data, and it is going to check for the mapping between classes. That's it. Third is initialize. In the initialize, all your primitive objects will initialize to the actual value inside your class file. Integer value 1 equal to 10, we have given it in the program, right? In the prepare statement, it will default, it will put some value to your value 1. But in the initialized stage, it will put value 1 as 10. It will put value 2 as 5. So that is what your class loading subsystem is going to do. It is going to it is going to load a class file. It is going to link and verify. It is going to initialize. That's it. Let's not worry about other things, exactly what JVM is going to do inside the class loader. Even from a performance engineering perspective also, I think this class loader, let's not even worry about what is going to be there inside the class loader. That's a JVM part. But just for our architecture perspective, it is very important to understand. In a lot of interview, you will question. I mean, if you're even going for Java performance engineering, the questions will come around how JVM works, what happens inside the class loader, what kind of things will happen sequentially in the class loading subsystem. Somebody who is very good in Java, if you wanted to test your basic Java knowledge, they might have asked these questions. So from that perspective, class loader, we want to know what is what happens inside it. Okay. Next is our main component, JVM memory. So you have you're executing a class file in your Eclipse. Right click, run as a Java application. First part is now classes are loaded. Second, for the execution, all your variables that are going to define there, right? You're going to define integer, boolean, strings. You're going to create objects. All these runtime data, right? All this the memory that is required for your runtime data is going to be handled by JVM inside the component called JVM memory. Okay. Inside JVM memory, there are going to be 5 components inside that. Method area, now it is called as metaspace with the newer version of Java. So method area is no more, but it's just a name change, and the way Java is going to handle memory efficiently. Right? Metaspace is one. Second is the heap. Heap is our core area of objects that are going to get created. From a memory perspective, if you look into it, right? If you're going to allocate 2 GB of memory for your JVM, you always talk about heap size. So heap size is the majority of memory allocation will go there. So heap is going to have all your objects. 100 users, 200 users are going to use your application. They are going to use your class file. They are going to create an instance of your class file. All these objects, all this memory of your objects are going to be allocated inside your heap. Okay, so heap is a very important area which we are going to go in depth when we are going to start our third day 3 or day 4, when we are going to talk about memory analysis, heap dump analysis, leak analysis. We will start from the memory basics before we go to the memory analysis. Okay, so from a understanding of an architecture perspective, this JVM memory is the main component, which is going to have metaspace, and second is going to be your heap. Third is the stack. Stack again, when you look into your Java program, right? We talk about primitive data, like your integer, boolean. All these primitive memory will be allocated under the stack memory. Okay, all your objects, non-primitive, right? That will be allocated in the heap. So to keep it simple and for our understanding, the heap and stack is all about. I'll go to the uh, here, right? Yeah. So stack and heap is all about your stack will have the values, like my integer value 1 is 32. Integer, if you go to my class file, right, to give a comparison of how exactly we going to create the programs, how exactly it is going to related to the architecture. So these things will go into stack. Okay, and the object which we are creating, which is going to occupy a space, right? We are going to load the entire thing as an object. So whatever that memory that is required for this object will go to the heap. This object or array will go to the heap. The reference of this, right? Say I'm referring this entire heap object as an my OPER. Okay, this reference will be there in the stack. Okay, it's very simple. JVM will handle it very intelligently, right? All the things that are required only for that method, like your the value 1, value 2, whichever we are having it in this program. This is not when you come out of this program, right? This is not required. This will go off. So whichever is temporary, it will be kept here. Minimal memory is required. Minimal memory that is required will be kept in the stack. And the object which you are creating, right, the entire memory for your program to work, that will be there in the heap. The reference of that would be there in the stack. Okay, say for example, you have your apartment, right? You will occupy 1,000 square feet of a space. That entire space is there in the object in the heap. But the reference is an address, right? Saying somebody is there in Mumbai, Andheri, that is an address. That address will be saved in the stack. It's a very maybe a bad example, but still for you to understand how this works, the entire space of that object will be stored in the heap. The address of that will be reference of that will be there in the stack. So that's how the stack and um, heap is defined and handled by JVM. And then there's something called native method stacks, right?
So
Native.
selection happens where it deletes, like clears the unreferenced objects from the memory from stack or heap.
So what happens is when you remove a reference, okay, the reference 1 will go out of the stack. When GC happens, right, it will look for the references. If there's a reference, say reference 1, it is related to object 1, object 1 related to object 2, object 3. Once a reference is deleted from a stack, then those objects will be available for the garbage collection. So that is how it works. The reference will be deleted by your programmer in the code, right? You have to remove the reference. If the reference is going to be there, always unintentionally it is left out by mistake. That is where the leak will come into picture. So if you properly remove the reference, then at some point of time reference will go off. The object in the heap will don't have any reference, which means when a GC is going to happen, it will go and delete the objects.
Okay.
Yeah, and again, all these topics will go into deep dive when we talk about the memory analysis. But from a high level, from architecture perspective, JVM perspective, the heap is going to have your entire objects memory. Your stack is going to hold the primitive integer values, boolean values, and it is also going to hold the reference of your objects. Okay, native method stack is going to have your say for example, from a Java program you're going to call Python. From a Java program you're going to call a C. All the memory that is required for you to call the external programs, that is going to be available in your native method stacks, which is not actually much relevant for us from an engineering perspective. Will not deal much about it. Okay, anyway, because once you call this external program, that external program is going to work on its own, and that is anyway not is going to be in our scope from a JVM perspective. Okay, it's going to be more of a kind of an external call, right? But whatever small memory that is required for us to call that external programming language, that is what it is going to be there in the native method stack. PC register, it's going to hold the execution list. Say there are going to be execution 1, 2, 3 line items. PC register just going to say for a particular thread, right? It is going to say you're going to execute a line 1 and line 2, line 3. It is just going to keep a sequence of executions instructions alone. It is not going to load anything. It is not going to load any class files or any of your objects. It is just a list of line items for your JVM to execute in an order. Okay, the stack and PC register, it will be allocated separately for each thread. Okay, there are going to be 10 threads on top of the JVM. For each thread, it will have its own stack. It will have its own PC register. Which means when I access my add to cart, one thread will be created. Inside the thread, one stack will be there for my thread. One PC register will be there for my thread. Whatever primitive integer that will create for me, like quantity equal to 1, the item equal to laptop, the item equal to water bottle, or item equal to mobile, quantity equal to 2. All these things are going to be in stack, and this stack will be created for my thread. For you, for your thread 2, you will have your own stack. So there won't be any clashes or any. That's what we call as a thread safe. All the data that is going to be part of a stack is always going to be thread safe, because each thread is going to have its own stack. Each will have its own PC register. Okay, and heap is a common area. Multiple people are going to access your application. All objects are going to create a heap, and whichever thread is going to create its own object 1, object 2 will have reference to that. So that is how the JVM is going to work, split it across as a method area, heap, language, JVM stack, PC register, and method stack. Okay. I talked about how the class loader works, how the memory works, and for everyone, right? Memory is a bigger concept. That is where we are complete engineering of your thread and leak analysis, GC analysis is going to work. So before every topic of memory analysis or thread analysis, we will again go and touch upon all these basics about how JVM handles memory, how JVM handles stack, how JVM handles your thread, and then we'll go into the engineering aspect of identifying leaks, identifying thread problems. Okay. And then the third part is your execution engine, where now your you would have known about the bytecode, right? All your JVM is going to create a bytecode, and then now when you're going to execute in a Windows, when you're going to execute in a Mac, right? This execution engine, the interpreter, is going to convert your mission, your bytecode into a mission understandable code, right? That's how we are saying it is a platform independent. So you create a program in Windows, you take it to a Linux box, and you go and execute saying Java followed by your class file name on, or you execute this .jar, right? Say this .jar I created in the Windows. When I take it to Linux box, I can execute it. When I take it to Mac, I can execute it. Because what will happen is the JRE in that Linux box or the JVM inside in the Linux box will take this jar file. The interpreter in this JVM will convert that bytecode into a Linux understandable language, and it will execute it. So you see there is something called native method interface and native method library. So that's how it is going to work. I have given the jar file. I'm importing into my Linux box. I'm executing it. The JVM, the interpreter component in the JVM will call the Linux specific libraries, or Windows will call DLLs to execute it, to convert the bytecode into the mission understandable code, and it will execute it. That's an interpreter. Very simple conversion of bytecode to your OS understandable code. Second is the GC garbage collection component. Garbage collection is another component which will look into how to optimize the memory. It will look for all the references every now and then. It will have its own algorithm, which we are going to talk about. To clear up the memory, your machine can hold only 2 GB memory, 4 GB memory. You cannot keep on holding the memory, right? So GC will take care of fleshing out your unused memory, unreferenced memory, so that new objects can be created. So the GC is one of the component inside your execution engine. There's something called JIT compiler and hotspot profiler. Two are to improve our performance. The hotspot profiler will keep on looking into the execution. It will look for how to improve your performance. It will note down all the frequently used methods, frequently used execution items, right? So that what happens is there are multiple methods. Say a particular method 5 is called often. For instance, a method to provide you the product in an e-commerce site, it's going to retrieve all the products for say COVID-19, right? People are going to search a lot of products for COVID-19. So which means there will be a method to retrieve all the COVID-19 products like sanitizer or your mask. So what the JVM will do is it will keep on looking for the most frequently used methods, and it will find out COVID-19 method is frequently used. So it will tell that JIT compiler to have it pre-compiled. So it will have the mission code ready. So not every time it will convert the bytecode into your machine learning code. So the JIT compiler will make your that particular code pre-compiled. So the next time in it call, it is going to be super fast. No need for interpreter to work. So that's how the JIT compiler is going to work. Just-in-time compiler. So yeah, the execution engine is going to have 4 components: your interpreter, GC, hotspot profiler, and the your JIT compiler. Okay. So with this, okay, I'll probably pass it on for the questions for the demo class at least, right? We'll also talk about the 32-bit JVM, 64-bit JVM when we talk about the memory analysis. Any questions? Any? So since it's going to be mostly it's going to be our last demo class, right? Do you have any questions? Probably can spend 2-3 minutes or 5 minutes of your time taking any questions.
Yeah, yes, Prem. Like, see, when we discuss about CPU things, there are counters will be like system time, user time, interrupt time, all these things. Like, will we discuss in the coming classes how which thing makes this metrics come up? Like CPU is rising means this user time is high, user like system time is high, the interrupt time is high. Will we discuss all these things in our upcoming classes? What makes this to high makes high all these
Yes,
concepts?
yes. So when we are going to talk about the monitoring, right? We are going to talk about the Linux monitoring and Windows monitoring, and we will definitely touch upon all the important the parameters, the important counters which we are normally will look into it to find out the health, because all these tools are going to give hundreds of metrics, right? So which one we need to look into it, which is very important. What is the importance of this different metrics? We'll touch upon during our monitoring session, which will happen. So the first thing would be response time analysis next week, memory analysis, GC analysis, thread analysis. Then we'll go to the monitoring. That monitoring session, we'll talk about these counters.
Okay.
Prem, this is Kirti. Let us suppose we are handling some Java project in our office. We don't have a monitoring tools like AppDynamics, Dynatrace and all. So using this JConsole and JProfiler, using all these tools, can we monitor and get whatever the monitoring tools actually does with using these tools only?
Okay, so there are two differences, right? AppDynamics Dynatrace, it is going to be very, very user friendly, and it has its own agents which can give you a lot of data during an execution, during the in the production. From a monitoring perspective, the counters, right? All the important counters, Java counters, JVM counters, yes, you will be able to get it from the JConsole. You will also be able to, from a Linux box, from a OS level, You will also be able to get it using some open source, which I will show it during monitoring. I talked about Telegraph, all these things, right? Yes, from the monitoring, getting the statistics, getting the performance counter, pretty much you would be able to get it everything. Maybe not in a very rich UI friendly way, which Dynatrace will have it, AppDynamics will have it, but still we can also build something using this open source like Telegraph, Eclipse, Grafana, right? All these things, the gaps are nowadays getting very closed because of the open source thing available. So monitoring, yes, you will be able to do it. Second, taking a heap dumps, taking a thread dump, uh, using a profiling tool is not advisable during the test because the profiler will get attached to the JVM. It will have an overhead. So taking those dumps using the profiling tool is not advisable during a load test using the profiler tools, but you can do it through the command lines, right? It will show how to do it. But getting into this, when we're doing a single user profiling, right, we are getting into which class is taking more time, or which method is taking more time, which object is holding a lot of memory. So those things you will not be advisable to do it in the JProfiler or Visual VM again because of the overhead. That is where the instrumentation of your Dynatrace and AppDynamics is going to help you to figure it out. So Dynatrace and AppDynamics, they claim they have a very less overhead for instrumenting and getting this data. So again, there are two things, right? You profile your application before even do a load test, optimize your memory, optimize your method response time. That you'll be able to do it using Visual VM or JProfiler. From a load testing, from a production monitoring perspective, you will be able to get all these metrics through these open source or JConsole before even getting into a AppDynamics or Dynatrace. But do a deep dive to understand exactly which web transaction is taking more time, which method is taking more time during a load test and in production. That is where I think Dynatrace and AppDynamics are still going to be pretty useful.
So basically, you are telling that so if you enable these profiling tools, like they have a overhead compared to the monitoring tool like the AppDynamics and Dynatrace.
Yeah, during a load test or during your in production, right? Yes, definitely not. It is not advisable to use these tools in production or see the JVM in production is going to have a lot of activities that are going to go on, right? So to attach to that JVM during production or load test, yeah, JProfile is going to have a additional overhead, which
So
Dynatrace. Yeah.
then how to monitor during the load test then?
See, there are two things, right? One is monitoring. Second is the identifying the root cause or method which is taking more time, right? So during
Yeah.
your method level response times, your objects which are leaking, all these things you will pretty much have to do it before the load test. So, for example, if you do a single user analysis and then you go into the 5 user, 10 user, 50 user, right? Until that point of time, you can troubleshoot all these problems. You will optimize your methods. You will optimize your memory. Okay, once you go into the your execution during the load test or during your in production, you will be able to monitor. You will be able to monitor all these memory, each and every operating system metrics, the JVM metrics, all these things you will be able to monitor using JConsole or getting it from Telegraph. All these things you will get it. But to get into this method level response time, you can still use. It is not definitely advisable or recommended to use JProfiler during the big load test. Thousands of users are there. Attaching a JVM to a JProfiler is going to be costly. But still, if you already have a problem, right, in load test, you find out what exactly going on for a troubleshooting purpose. You can still debug it, right? And it's similar to your turning on logs. Right? Turning on logs is not recommended, but if you already have a problem to troubleshoot, you can turn on logs and you can go into look into what are the exceptions that is happening, and you can even the developer will add the logins to get the response time at the layer level, so that you can look into logs. The tool set Splunk will come into picture. So that's how it is going to work. AppDynamics, Dynatrace are good, or definitely good to have, but it's not a must to have.
Okay, basically you're telling that while initial phase of the testing, you using the less number of users, you do a test and find out the methods or the transactions which are taking high response time, and fix it and test it. And when you are doing for actual formal execution, at that time, don't enable all these tools to get a result.
Yes. Yes, absolutely. Yes, that's correct.
It's like instead of like 800 user test we are doing, when you're using a 200 users, you do it whatever the high response time, find out the transaction, work with the developers, fix it, and when you're doing the formal, just do 800 user test. That's it, right?
Yeah, I would say even not even even before 200, right? Lot of problems as a performance engineer, we have to get into even before. Get the individual APIs, get the individual packages, profile it, find out a problem. It will be really easy to find out a problem at that level, rather than combining everything into one single script, executing it under user. It will be difficult for you to profile the JVM. Because a lot of things will get loaded into JVM, right? And in your thread and objects, it will be difficult to differentiate it. So profile it one by one. As a single user, profile your actor card, profile your view card, profile your search products. So that is how you need to take what functionality wise, optimize it. So that is how we are saying for the performance engineer has to get involved very early in the life cycle to optimize your code to a best level. Rather than doing it late, optimization might not be that possible. You not even have a time to do it.
Okay. Okay.
Okay, fine. I think we'll end our session today, and we'll continue from Monday and the other topics. If you have any questions, you can reach out to me. Any questions related to the enrollment, you can reach out to Kumar Gupta. Mostly, it would be our last demo class from Monday. You begin it for all the people who are interested and want to enroll. If you have any questions on any further questions on the course itself, you can drop a note in the WhatsApp group, or with respect to the enrollment, please reach out to Kumar Gupta. Okay. Thank you, guys. Thanks for your time. People who have already enrolled, right? Let me pass on those Excel sheet filled up with the location where you should download the softwares, download the tools, download the sample applications. I will also upload my sample code, whatever I showed here, to some common SharePoint where you can download. Over the weekend, please set up your mission, whether it's going to be laptop or if it's going to be your some cloud missions. Probably download all these things, have your mission ready. Whatever I have showed you till now, right? Creating one or two programs, make your environment ready for a Java to work, your Java tools to work. Okay, that would be my recommendation for the people who have already enrolled. I will send all this detail tonight or tomorrow morning before you start your day tomorrow. Okay. Thank you, guys. Have a nice day. Have a nice weekend. Stay safe. Thank you.
Thank you. Bye bye.
Bye bye.